deep in the Allegheny Mountains of West Virginia, in the middle of a rugged 13,000 square mile expanse known as the National Radio Quiet Zone. A team of astronomers has detected a series of devastating high-energy bursts erupting from an unknown source far off in space.
So we've now detected hundreds of bursts.
And no one has a clear answer why.
There's always a danger, like, well, maybe this is actually ET. We gotta make sure we're doing the right thing here.
The small towns of West Virginia's highlands are some of the most isolated in America. But today, one of them finds itself in the center of a cosmic mystery. All because of this, the Green Bank Telescope, one of the largest movable objects on dry Earth.
The structure here stands almost 485 feet above ground level. It's actually taller than the Great Pyramid of Giza. We can see more of the celestial sphere here in Green Bank than can be seen from any single telescope anywhere else in the world. We can see 85% of the celestial sphere right here.
Life in and around Green Bank is heavily restricted by the needs of the telescope.
We don't have cell service here. There is no Wi-Fi. It's prohibited completely. Television is a little tricky.
The enforced silence around the telescope allows it to detect signals that few others can. For the past few years, astronomers have been using Green Bank to investigate a string of unusual signals called fast radio bursts that have been detected across the universe. When fast radio bursts erupt, they can unleash as much energy as our sun does in an entire year, in a fraction of a second. But by the time that energy reaches Earth, it's a mere whisper. And while astronomers have now detected dozens of different fast radio bursts, one of them is different from the rest, a mysterious signal they call FRB 121102. From the telescope's control room, Dr. Ryan Lynch directs the telescope to lock in on the target.
So the GBT sees a very small portion of the sky at any given time. So if you think about a really little tiny crater or mark on the moon that you might be able to see with your naked eye, that's basically the amount of sky that we're seeing right now. And the bursts only last for a fraction of a second. So we have spent probably hundreds of hours over the course of the last few years observing this object, and we've only detected a few hundred bursts. And if you were to add all of those bursts up, they would only add up to a few seconds worth of time when the source is actually active.
A few seconds that have set off a series of discoveries and made this one of the hottest topics in astronomy today.
When FRB 121102 was first discovered, everything got thrown into overdrive.
They could now track the location of the signal to the constellation of Auriga.
Once we were able to localize 121102, we realized that this galaxy has never been seen before.
Although they knew where it was coming from, they didn't know what was generating the signal.
When fast radio bursts were first discovered, they were all one-off events. That could be things like an exploding star, a supernova.
So when we start to see it repeat, that changes our whole paradigm of what it could be.
They began to suspect that the signal could be coming from a pulsar. Pulsars are dead stars that emit radio waves so predictably that NASA has discussed using them as cosmic beacons, guiding future space missions.
And you might think to yourself that we would be able to find some sort of a pattern or a regularity in when they're going off. But we've looked really hard and we haven't been able to find anything like that yet.
Astronomers from Breakthrough Listen, one of the largest projects to search for intelligent extraterrestrial communication, wonder if signals like these could conceal a message from a distant civilization.
Anytime there's a new astrophysical phenomenon discovered, I think, aliens are one of the explanations for it.
Radio waves can either be created by natural cosmic events or artificially by intelligent species like us. Although the energy emitted by 121102 is staggering, equivalent to 500 million suns, SETI believes it's still a possibility that it's artificially created.
Part of our assumptions in the SETI field is that we are just getting into radio technology. We've only had it for 100 years, and other civilizations could be far more developed than we are. I don't think that there's some fundamental limit to how strong a signal some intelligence could create if they wanted to.
The question for astronomers, then, is not just why this signal is so strong, but whether it carries any information.
When one gets a radio signal from outer space, you automatically start to think about extraterrestrials. While we can't rule out all FRB sources, we're pretty confident that FRB 121102 is not an ET source. With ET signals, one would expect a lot of information to be encoded into that signal, and all the information that we're getting from this burst has a natural explanation.
To demonstrate what an encoded message could look and sound like, Andrew Seymour has created one from scratch. Each pixel in this image of the Green Bank Observatory's logo corresponds to a different frequency and time. Think about them like a series of notes on a sheet of music.
Here, instead of having 7 or 12 notes that we may have on other instruments, we have over 1,000 notes being played here.
When all of those notes are played together, we see and hear this. And if we were to broadcast those frequencies into space,
If another civilization was recording with computers the same way we are, they would see this image come across their computer screens.
but when Andrew analyzed the signal coming from 121102, he discovered something very different.
And one may think that there's information coded in that, but it has a natural explanation.
As strange as the sound and image may appear, Andrew finds nothing unusual or alien about them. Instead of a message, he sees a snapshot of an explosive moment from a distant galaxy. Many still believe that if we were to receive a message from a distant civilization, it would come to us cloaked in a radio signal like this. And that is one more reason why every new radio burst is met with such anticipation. Now that scientists have determined that the source of the unidentified repeating signal is unlikely to be a supernova, or a pulsar, or even a message from beyond our galaxy, they've turned their attention to one of the most exotic and violent phenomena in the universe: magnetars. Like pulsars, magnetars are super dense remnants of stars that have gone supernova.
Imagine an object with the same mass as 500,000 Earths, but squeezed into about the size of a city. That's the equivalent density of taking every person on the planet and squeezing them into a sugar cube.
What sets them apart is their magnetic force.
Magnetars have the strongest magnetic fields in the universe. If you were to take a magnetar and place it at the distance of the moon, which would not be a good idea because it would destroy the Earth, but in the process, it would also erase all of the computer hard drives and credit cards on the Earth because of the strength of the magnetic field.
When a crack forms on a magnetar's rigid surface, it can set off a starquake, ejecting so much energy that it can be felt billions of light years across the universe. And the radio waves coming from 121102 tell us something extraordinary.
We saw that they were really twisted up, kind of like a corkscrew. And the degree of twist is higher than in any other source of radio waves that we've ever detected. So we think that this could be a sign that FRB 121102 is itself living somewhere near a black hole.
A white-hot magnetar nestled in the orbit of a black hole, firing off instantaneous bursts of energy that billions of years later can be observed from Earth.
Even though we're only detecting the bursts now, they were actually emitted hundreds of millions to billions of years ago. So it seems like we're watching this drama unfold in real time, but in fact, the objects that have created these bursts may very well be long gone.
Decoding FRB 121102 has revealed a part of the universe we never knew before. And it could also help us better understand the explosive magnetars discovered in our own galaxy as well.